Hello, I'm the little person down the front, and they have put me in the naughty corner, which means I hope you can see me all right. Yeah. If someone at the back has any questions, I might not be able to see you over the wall. So if somebody waves, and then if you all keep waving, it will be like a Mexican wave, and I'll see that somebody somewhere has a question. All right? Okay, so I will get started. All right. So thank you, first of all, for having me back at SQLRally Nordic. This is my third time here, and I'm delighted and privileged, as always, to be here, so thank you very much. So who am I? My name is Jen Stirrup. I realise probably 90% of you are here for the accent, and because it's the end of the day, you want something nice, soft and relaxing to listen to while you fall asleep. Right. For the rest of you, we've got work to do. And you can contact me here. Here's my details. You can see those. Yep, jenstirrup.com. Now is a good time to leave if you've mistakenly come into my session and realise you should be in somebody else's. Yeah. No one will look at you or be all right, okay? So I wanted to talk to you about data, about poking holes in your data. Yeah. Now, I don't know about you, but I like practically nothing better than telling companies things about their own data that they didn't actually know. I'll give you an example. I had a customer who had lots of spreadsheets. They were honest up front and said, yes, we've got spreadsheets all over the place. We live on pivot tables. So I said, okay, let me get a feel for your business. I'll have a look at these spreadsheets. And I looked, and then I found a very strange thing. They were using the median everywhere. Now, in case you're wondering, you probably remember from school. Hello, I'm in trouble, I think. Okay, thank you. Right. So the customer used the median everywhere, and that was fine. The median, as you remember from your school days, is where you get a sequence of numbers and you order them from the beginning to the end, and you take the middle number. There's nothing hard about the median, right? Lots of people nodding heads. Apart from this customer calculated the median incorrectly, right? Now, what they did was they did not sort the data before calculating the middle number. So every time they sorted their Excel table, they got a different median every time. So it was to do with the length of time that they took to resolve service calls. And I went back to see them, and I said, well, you're calculating your median incorrectly. You said it was 90 days. Actually, I've found that it's closer to 45. And I said, so how long have you been calculating the median wrongly for? And they said, well, about 2 years. I said, seriously, 2 years? Why? They said, well, it's actually been wrong for 4 years. 2 years ago, we changed the calculation. We never looked at it again since. And we changed it 2 years ago because it was wrong the first time. I said, okay, the median, you've had it wrong for 4 years now. How widespread is this throughout the organisation? At which point he was chalk white and did this sort of movement. And then he realised, and it is very simple and straightforward, where people make a really small mistake and it permeates through the whole business. Now, I had only been at the customer site for 2 days. And I was not popular by that point. But that's the thing, I love telling people things they didn't know about their data. And the purpose of this session is really to help you to be that person, yeah? People will fear you, they'll admire you at the same time. It's quite interesting. It's a good mix. So it's all about the analyst journey. I know that this is an advert for Past BA, but the advert, it says something very similar, very strong about what analysts do. They discover data, they integrate data. Now, usually you integrate your data sources first. Putting those data sources together is what gives you insights, yeah? But you have to validate the data, and that's what I was trying to say this morning in the panel discussion. I asked the question, how are you going to cleanse data from devices? How are you going to put those together? It's a very complex problem. And it's clear for the example I've given that people get this wrong, and they get this wrong all the time. I'm not saying that you do, I'm probably preaching to the converted, but you probably clean up after people who get it wrong all the time. I'm just giving you more tools to go off and clean up after more people, because that's what happens. Okay? So why do we look for patterns? It's something that we do all the time. Business analysts are expected to be a mix of technical and a mix of business. Yeah, it's a very organic skill set. Yeah. So Terry Pratchett, any Terry Pratchett fans? Yeah. You might recognize this quote. I'll be more enthusiastic about encouraging thinking outside the box when there's any evidence of thinking inside the box. Yeah? And it sometimes feels a bit like that. We're expected to be creative problem solvers with our data. Because the big phrase this year is all about data storytelling. How do we tell stories with the data? Well, first of all, what we do is we start to try and ask questions of our data. We try to predict what are the most important things in the data. We don't always get this right. There's an example where the US government didn't get it right either. They set up some neural nets that were supposed to be about training tanks to tell the difference if there was a tank present or absent in the picture. You think, well, that's quite simple, isn't it? You know, you just do lots and lots of training and keep showing the visual system, tank, not a tank, tank, not a tank. How difficult is it? But what they did was they actually took pictures. The picture showed a forest scene. One forest scene had a picture of a tank in front of it, and the other forest scene was just that, just simply trees. And they trained the neural net, tank, not a tank, tank, not a tank. But what they found was they started to show it worked really well at first. Then they actually found when they gave it new photographs, the system failed, and it failed miserably. And what they had done was actually train the neural net to detect the absence or presence of daylight, because they'd taken the two pictures at different times of the day. So the one with the tank was taken bright during the day, and the one without the tank was taken at dusk. And all they'd done is train the neural net to tell the difference between a light and a dark photograph, not whether the tank was present or not. So your variables and what you're actually looking at is really important, and lots of people make this mistake. And it's very important to visualize the data as well. Now, I think when you analyze data, it's half of it is the statistics, half of it is the numbers that lie underneath it. Testing those numbers, testing your results. So when you write a business intelligence report and reporting services, you do tend to go back and think, is my data correct? How do I know it's correct? And you keep testing it. It's part of that project's life cycle. But visualizing the data allows you to see patterns in the data that you didn't expect to see before. Now, this is actually taken from Gartner. There are different types of analysis that you can do on your data. So the first type of analysis is descriptive data. Descriptive statistics, things like the mean, the median, and the mode, really, really simple ones. You would be surprised how many customers I catch out all the time because they simply have not done the very simple tests on their data. Another example, I did some work for the NHS in the UK, the National Health Service, and they wanted to know how many bed days somebody spent in hospital on average with a certain condition. Now you think, well, average days in bed, that's easy. You know, just take total number of bed days, total number of patients, divide them. You've got the average. But when I looked at the data was really messy. And we had people who had stayed in hospital for minus 185 days. And the reason for that was because they'd swapped around the dates the patient entered hospital and the dates when they left hospital. So they actually left hospital before they arrived. Does that make sense? So you ended up with this negative number, which was really strange. And your average actually turned out to be 15 days on that messy data. And then you thought, well, actually, you've got this terribly skewed, dirty data, and nobody had found it before. And the reason was they just did not look for a minimum and the maximum number. You'd be surprised how many people you catch out just by doing a min and a max, how much dirty data you find. It's something, unfortunately, that happens quite a bit, I think. So then you've got diagnostic analysis. You're trying to work out what are the key drivers that made something happen. How did we actually do that? And that's when people start to ask why in the business. Why did this happen? And then we move on to predictive analytics, something that we look at when we look at Azure ML, Azure machine learning. And then we've got prescriptive analytics as well. It's kind of the holy grail of data. What should we do next? What's our prescription on what action should we take? Okay, so revealing patterns in the data. I think data visualization and data analysis go hand in hand, and I'll give you a quick example. Now, on the left-hand side here, this is an island off the west coast of Scotland, which is where I'm from. And when we look at that picture, we see a face, yeah? Obviously, it's not there, but instinctively we start to look for patterns, and we do it before we think about it. On the right-hand side, we've got a picture. It looks like a face, but it's actually a construction of fish and chicken. It is quite cleverly well done. So you might see patternicity happen a lot. You know, these people that say they see religious figures on the side of a building, you know, that sort of thing. People see patterns that are perhaps not there, or maybe they are, who knows. And the idea is the brain is a belief system. It has things and heuristics that we use all the time. And there's an environmental benefit to finding patterns that are there and finding which ones are there, which ones are not. Okay. So, when we analyze data, we look for patterns. Okay, so I'm going to talk a little bit about this. Now, before we do, I'm going to have to apologize. Is anybody Greek in the audience? I'm sorry, I'm not picking on you individually. But thank you very much for you for admitting. No, it's okay, I'm not going to. I know you guys are having a hard time, it's not your fault. So what happens is, and when we looked, they've done some research which looked at the data that Greece submitted when it joined the European Union. And there's a case, I think, going on at the moment where they're starting to look at what happened to that data. And the idea being that some of the data looked like it was going to be quite strange. So they did some studies which used Benford's law. Now, the study on its own suggested that the Greece data was fraudulent because it did not meet this particular law I'm going to talk about. But actually, it's easy to find headlines and patterns that are there or sometimes not there. Because actually, is anyone from Belgium? No? All right, I can talk about the Belgians. All right. So actually, the Belgian data doesn't meet Benford's law data either. But of course, people just see one part of the pattern, don't they? Then make a headline out of it. But it's interesting because I'll talk a bit about Benford's law. It's something that we use when we are examining data, and it's quite an interesting phenomenon. Anyone from China? No? One? Okay. Sorry. You know when you get your feedback back after you do a presentation? This isn't going to go well. So what they said was Benford's law raised doubts about Chinese law as well. I'm the first to admit the UK data isn't fantastic either. Don't worry. Yeah. So, but what they found was that when you look at the data, the Chinese data gets rounded up quite a bit. Because normally in the West, what we do is if it's over 0.5, we round up. If it's less than 0.5, we round down. But when you look at the data, Benford's law suggests that there was a problem there with fraudulent data. But when you look at it, you see actually the pattern is a lot of rounding up. And maybe we've got this other cultural thing happening where they actually round up more often than we do. You know, it's just a different perspective in the same data. So what I'm trying to say is statistics is a good starting point. It's not everything. And you have to look at the bigger picture, which is why data visualization is really important as well. So what is Benford's law? In many real-life sources of data, the leading digit is actually number 1. Yeah. So if you've got some data, the first digit is going to be 1 30% of the time. Larger digits occur with lower and lower frequency until you get to the number 9, which occurs less than 5% of the time. And this happens, we can see this in data. So the reason that this was noticed was a statistician called Simon Newcomb. And what Simon Newcomb did was he had one of these really old, well, they're really old now, it would be end of the 19th century. Newcomb picked up his book in order to do some logarithm results. I don't know if you remember this, but I remember the days when we had to look up our maths in a book and you didn't use it in a calculator. So you got these little paper pamphlets and you had to open out the book to find out where you were. Anyone else remember that? I see a few nodding heads, and I see a really confused people under 30. All right. You know these, yeah? So what happens is when Simon Newcomb picked up his copy, and he found that the most thumbed part was where the number 1 appeared. And he thought, well, why is this one so popular and the rest of the book isn't? And being a bit of a numbers person, he did some analysis on his book. Isn't that great? Obviously, long, long winter nights wherever he was, but he found this pattern. So the first digit occurs 30% of the time. Then we've got the second digit as well. So we see it not just in the first digit, but we see that the second digit starts to appear too. So you can apply Benford's law to your own data as well. Apply it to people's expenses. That frightens them. Yeah. So what happened then was a gentleman called Mark Negrini, and you can get his book from Amazon. It's a really interesting read. He said that Benford's law could be used to look at fraudulent data. He said that human choices are not random. Yeah. So if people are fiddling their expenses, they're more likely to put in an 8 or a 9 at the beginning of a number than they are a 1 or a 2. So if you're making numbers up, they don't follow Benford's law. People who like numbers are such a suspicious lot, right? You know, so he started to look at these numbers to see what happened. I'm just going to skip ahead. I wanted to show you. All right, well, I'll come back. So Benford's law actually applies to a number of things. So we can use it where the number, you've got more than 500 symptoms of the number. So transactional data is quite good for that. Accountancy data, such as journal entries, you should find that most of them start with a 1, slightly less amounts start with a 2. Purchase orders, stock prices, and expenses. It does not work for every single case, okay? It is just one of these funny statistical laws which appears now and again. And it's not the be-all and end-all, but it's a great place to start, and it's also a good place to have some fun with data. So what we find is Benford's law does not hold where we have things like telephone numbers. They are generated numbers. They're not naturally occurring. It also doesn't apply to things like heights. So I'm about 152 centimetres. I'm guessing someone now a foot taller than me is going to be 180 centimetres. So the first number there is always going to be a 1. So it doesn't apply to data where there's usually a defined starting point and a defined ending point as well. Places where there's a cap, so you know those awful machines which you take money out of them and it charges you money to take money out of your bank account. Do you get that sometimes in service stations? So if you were to do an analysis on the fee, you'd probably find it was just maybe 10 or 20 euros. It wouldn't be much more than that. It doesn't work in very small data sets as well, so don't run out and try it on absolutely everything. Okay, so example data audits. If you are looking at data, I suggest you just do a quick survey of the data, and I'm probably speaking to the converted, but you'd be surprised how many people don't do that. They find silly things in their data all of the time. So strange behaviours, people bypassing permission limits. Now, I see some strange things in accountancy departments, and some of it is about the processes, whereby it tends to be about the processes being bent in order to get something through really quickly. And I don't like those circumstances when I see them, because it doesn't protect the employer, but it also doesn't protect the employee as well, who's in that position. I'm a fan of trying to change the process if we can, and make sure everything is followed within some sort of due diligence. Okay. So I'm going to show you a quick demo, just so you can see it. Data visualization is a great way of helping you to audit the data as well. It's not just about the stats. So Benford's law, when you see it, is actually quite simple to follow. So what I'm going to do is I'm going to jump to my other screen, and here we are. Yeah, that worked. Excellent. So what I'm going to do, yeah, that works. Okay, good. So what we see here is occurrences of this, of Benford's law here. So what I've done, I've taken some of the Eurostat data, which basically is just the GDP data, and that is actually the blue line here. So a lot of it starts with 1, some starts with 2, some starts with 3. You see a slight jump here. Now the red line itself is actually Benford's distribution, and that's just a very smooth curve. So when we look at the actual data, the data looks like this. I'm just going to increase that. That sort of thing is really easy to graph, so you can see it. But then you can start to see how much do things start to deviate from that. So you could do some analysis to say, well, what's the deviation from here, from this point to that point? But you can see overall it sort of follows a line. You can do that in Power BI really easily. But the thing I'm most interested in showing you actually is a bit of R. Now I'm just going to start up Zoom it. I like to pretend it's for your benefit, but actually it's for mine. My eyesight's getting worse and I have to zoom in all the time so I can see the code. All right. Has anybody used any R before? A few, 1, 2, 3. Okay, about 4 people. All right. So don't worry, I'm going to assume that nobody has seen any of this before. All right. I know it's late in the day, and I know my voice is probably making you fall asleep, but hopefully you can stay with me for the next little while. So what is R? Well, what R is, it's an open source statistical package. And the reason that people use it is partially because it's free. It's also very, very popular in statistics, and it's becoming more popular in business analytics as well. Now, it's actually open source software. Now, you do get a corporate arm of it, which is run by Revolution Analytics. You may have seen the news recently that Microsoft has bought Revolution Analytics. So where is the place for R? Why have we got open source software in Microsoft? And I think there's a few things there. Lots of people are already using R. It's one of the most popular programming languages. It's number 15 or something like that out of the total list last time I looked. It's also a skill which is starting to attract a higher salary. So that in itself is always a good reason to go and learn it, right? Yeah. It's also very interesting because it's actually got, when I started talking about R, it was about a year ago, and it had 5,000 free packages then. It now has over 6,000 packages. And because it's free, you can go and download those and use them and call them as you like. Now, R, when you download it, is not very pretty. Yeah, it's console based. For those of you who are old enough to remember using consoles all the time, like I am, you probably will find it's just like riding a bike. You just start to use it again. But for people who are not used to consoles and used to typing stuff in like that, it might be a bit of a learning curve. But once you get over that, it's actually okay. Now, the reason you might want to use R is I like to be able to show how I got my numbers, you see. Now, sometimes when you use Excel, for example, or Access, if you take some of the formula, you don't know how it got that number. And I'm a consultant, I need to be able to explain how I got that number. Where does the data lineage come from? And if I use Excel or Access, I can't always see that. I have to go to Books Online, I have to go and try and work out how you got that number. And sometimes if you use Excel, put the same data into Access and use something like net profit value, you might get slightly different results. There's nothing that makes business managers more nervous than slightly different numbers and data. Because what that means is they will trust neither source of data. So I like just to be able and use R as a way of proving what I've done. Another reason I think it's useful is because it's about asking that question of the data, how accurate is it? And I don't know about you, but I go into customers so many times and I find that they don't survey their data at all. And that's why things pop out at me, which I go and talk to them about, and they're absolutely stunned because they never saw that before. And I think using something like this just helps you to have a look at the data in a different way. There are other tools to do this. Excel has got a stats add-in as well. You can go and download that, and that's very useful. It's not the only one. I just suggest this one because it's free, partially, and also because R is going to become more apparent in the Microsoft stack. It's already in Azure ML. So if you're interested in using Azure Machine Learning, I'd recommend you look at R. There are some algorithms pre-baked into Azure ML at the moment, and that's fine. But using R means that you have the flexibility to keep replicating those results. You can use it offline, test your data, and then put your R script into Azure ML. And I think Raphael's already talked about that today, so I'm not going to go into detail about that. Okay, so what we have here is when you install R, the first thing that I would do is install RStudio as well. Just watch the bitness of it. So if you have 32-bit R, then you must use the 32-bit RStudio. Oops, what I wanted to do, oops, apart from showing my desktop. I'll show you, I'm going to come back to that. I want to show you rseek.org. Now, if you can imagine, looking for anything in R is really hard, right? R is going to be a really, really difficult search term. You're going to find R everywhere. But if you go to rseek.org, it's actually a cut-down version of Google, which goes straight for approved R websites and approved R blogs by the R community. So if you're looking for any information at all, rseek.org is a great place to start. Obviously rstudio.com. So this is the IDE for R. And I recommend that you do that as well, just to get yourself started. Yeah. Download R, I think, from Project R. Project.org. Okay. So install R first, then look at RStudio. And when you get stuck, look at rseek as well. And that's a good place to start. Yeah, that's your 3 search terms. You have those, and you'll be fine if you get that far. You'll be rocking after that. Okay, So what I want to do is I'll show you the output first, and then I'll show you how we got there. Okay. The reason I do that is because otherwise I'll be showing you lots of little bits of code at this late hour, and it won't go in quite as well. Okay, so this is a motion chart. Now you probably see these in Power BI, but if you don't have Power BI, what you should be aware is that R has some very strong data visualization in its own right. Yeah. So if you can get over the fact that there's a tiny little bit of coding involved, you can get some quite quick results quite quickly. And let me show you how this works. Okay. So what this shows you, in the bottom we have fertility rate, and on the y-axis we have life expectancy. Yeah. So I'm just going to, so what we see here, it shows you basically that over time life expectancy goes up and the fertility rate decreases. So people live longer but having less children. You know, Hans Rosling did The Joy of Stats. Same data, pretty much what he did. But the bit that interests me is you can actually filter this data as well. This is all done with R. Yeah, I'll show you the code in a minute. I want to show you Rwanda. Don't worry, I'm not going to jump about the stage the way Hans Rosling does. He's a much better presenter than I will ever be. I just recommend that you go and look up YouTube and find his stuff on there. Recommended. So I want you to watch Rwanda, which you can see just there. Okay, so over time, we see that the life expectancy is about 40. Yeah. We see it start to increase, but then we see it nosedive in about 1990s and then goes back up again. And we can play that back again. So what we find in the year 1992, 1993 is that the life expectancy actually went down to 27. Yeah. And what that tells you is it's to do with a 100-day war in Rwanda. Over 1 million people were killed in obviously 100 days, and the life expectancy of people in the country went down to 27. And what the motion chart gives you is the ability to see the patterns in the data. So visualizing data is actually very important to see the patterns in it. Very glad to say it starts to increase again, and the life expectancy at the moment is back up to 60. Yeah. So what we learn from visualizing data can actually help us see the patterns. So when you see a motion chart, it's not just a toy thing. It's actually using the fact that when we visualize data, we use motion all the time when we look at something. Yeah, and there's psychological studies which show that, and that's what that's given you, is motion to look at data. Now the code for this is really simple. If I can do it, you'll be able to do it, no problems. Okay. I'm going to talk to you a little bit about R, the actual interface. On the left-hand side here is all the code. I'm just going to zoom in. You don't worry about reading the code, I just want to give you the headlines. I'll put this in my blog afterwards, and I'll refer you to the references where I've got some of this data as well, and some of the elements that I've been using. Now this is the file, so obviously you don't want to keep loading in console command lines all the time. So an R file is basically where the script is loaded. Yeah. So anything .r is just simply an R file. And that's your console down here is where the commands are executed in order to get the data back again. What we have here is a history. So you can see basically if you wanted to run any previous commands, the history is over on the right-hand side. Now the power of R really is that it gives you lots of variables for looking at data. So the way that I see R is like a calculator, but it's the power is actually the variables. Now you can actually, you don't have to type the variables, it does it for you. So you could have a whole data mining model and just give it a variable name and refer to that name in your code. If it's meaningful to you, it's such a nice, concise way of doing it. I really like that. And if you want to install packages at the bottom right-hand side, there are lots and lots and lots of packages, 6,100. I'm not obviously going to go through them all. So the packages are there. So what you do is you click on the install button, which is this one here. And then we can see that we get this package window arrive just here. Yeah. And then all you need to do, it auto-suggests packages for you, so I'm going to call it data. And then you can start to see the different packages. It will go and downloads the packages for you using CRAN, which is the Comprehensive R Archive Network. You can see the name of it here. So when you see CRAN, that's basically a lot of academic institutions have set aside some servers where you can go and download R. That's all it is. It's for free. Okay? Okay. So what we have is all the, if you want to use the packages, basically you just tick the box. So if you've ever done any programming, like C# or something like that, you have to call the libraries before you use them. And that's what these are. Now I'm going to zoom in on that. Now most of you will be familiar with setting up a SQL table in a script, and you tend to say something like, if table exists, then the table name, then drop the table, then create the table. It's something that's quite common. You see quite a lot in SQL scripting. And these bits of code does the same thing, the ones that are highlighted. So basically, if the WDI package is not installed, we've got the notes there, the note being the exclamation mark, then install the package WDI. So what is the package WDI? I'm going to show you. We have help down the bottom right hand side. And one thing that's nice about RStudio is that it has the help package just down here. Yeah. And it means you can refer to it as you go along. So search here. So I'm going to type in WDI. And what that is you can go and look up the World Bank. And I'm going to do that for you now to show you that. World Bank. Should be there. Just thinking about it. Oh no. Alright, so what the World Bank does, I'm just going to change that so it's in English so I can read it. It gives you lots and lots of data that you can go and play with, and R accesses this directly. Yeah, it has, the World Bank have provided some APIs which mean that you can go and access the data. You already have this in Power Query anyway. You can do an online search, and if you type in World Data Bank, it will go and get the data for you. R does the same thing, so it's quite familiar to you, I think. So what we have here is there are lots and lots of indicators that tell you. So we have climate change, economy and growth. We also have a lot about education as well. And when we go back, when we look at R on its own, what we need to do is, with the first few lines of code, install the packages if they are not there already. And now I could just have put packages and installed it here, but I thought it would be useful to start off with some code which is already a bit familiar to you. Then what we need to do then is call these libraries. Now, I've got a library here which is WDI, which is the World Data Bank Indicators. That's all that is. Now I've got this library which is called Google Viz. The reason it's called that is because it's trying to give you some of the visualizations which are in some of the Google APIs. So that's what that is. It's also in Power View as well, obviously. I thought you already know how to do that, so I won't show you that. You can see how to do it in here. So that's all that is. So once you've installed the packages and called the library, can you see it all right? I'm going to move this code up a little bit. So I talked earlier about using variables. We've got some variables here. So I've got one here which is called WDI indicators. And what those are these actually refer directly to the indicators that the world's data bank use in order to describe their data sets. So, for example, I'm just going to copy and paste this one. We'll put it into here. So let's see if we can find it. Find an indicator. Right, so, oh, it doesn't tell you. All right, so I'm just going to quickly look it up there. Oh, web page not available. All right. Right, here we are. Okay. It's thinking about it. So this indicator gives you the number of total births per woman, per female. And you can see all of the detail here. And the actual indicator name, you can actually see the data here. So what we've got is fertility rate. So that data actually comes from the world's data bank. And we've obtained it from here. And the reason we've managed to load that data into R is this very simple line of code here. Now what we've done is we've taken the data and assigned it all to a variable, which is called WDI indicators. So it's actually quite neat, because this is a variable for a data set. Now it's actually a data frame is what it's known in R. If you were using reporting services or something like that, you would call that a data set. It's the same thing, but you're just using the name WDI indicators to refer to the data set. And the data set is from the world's data bank. And it's going to go indicators to give you that particular data that we just saw, which is fertility rate and longevity as well. Now, that's all very well, but those aren't very readable. So what we've done here is, instead of just simply calling it the indicators, because that's not very readable, what we've done instead is simply call it fertility rate. So what's nice is you can actually rename. So we've got WDI indicators, which is the actual World Bank names, and then we've given it our own names as well, just so it's a bit clearer. So I've got something here which is WDI data. So what that's going to do is it's going to go off, and it's going to go off to the World Data Bank. It's going to search the World's Data Bank API for all of these indicators. It's going to do it for all of those countries. And you're going to give it a date and time as well. Yeah. So basically I'm looking at it from the year 1960 to the current date. So we're going off to the World Data Bank to get a lot of information all at once. And we can see that here. So we start off at 1960. So I'll just put that data right back there. So that's our starting point. We see that in the code. We've got fertility rate here, and then we've got life expectancy. And then if you go back to the code again, what we want to say is column numbers. So basically what we're doing here is assigning a variable column numbers, and we're doing a match on it. They should match. So we're saying the indicator matches the actual name that we've ascribed to it. So then this bit of code here is probably quite an interesting bit. GViz motion chart, I know it seems a bit confusing, but what that does is it goes off and tells R to go and create the charts that we just saw. So basically it's a function, and once we populate that function with the data that we're looking for, it will go off and plot the data. You have to tell R that it needs to go and do that. And so once you try this a few times, have a go at using variables and assigning your data to variables, and then using those variables and functions. And once you try it a few times, R can do some pretty powerful things, because this is only really about a page of code. Oops, sorry. This is only really, in fact, it's 29 lines of code. And some of that is actually comments as well. So with 29 lines of code, we've managed to get ourselves something like this. So once you learn the functions and the variables and things that you're using, you can actually get yourself quite far quite quickly with it. Now it's actually got a package for Benford's law as well. So again, what we can do is we would install, if you want to use the Benford package, for example, we've got the packages here. So the first thing we tend to do, the sequence packages, make sure we've got it installed first. There's a few different ones for Benford. We could install both of these just to try them. But when we actually look at the help file, which we will have a look at, you can look up the help file and it'll give you some clues about what the function is doing underneath. So there's lots of information here that gives you all about the various functions. But the thing with this particular data function for Benford is that you usually get sample data sets to try it as well. So if you're interested in learning a little bit about R, just run through the help files and have a look at the data sets they already give you. So the library that we're loading here is the Benford analysis library. And if I want to run that, I just need to highlight it, and then I can run it. So when I do that, I'm just going to pull that up, sorry, so you can see it. You can see that the code just appears in the console. So that just means it's loaded the library for Benford analysis. So if you wanted, you could throw your own data at this as well. If you want to assign data to it, you can actually import a data set from a text file or a web URL. If you want to go and use Azure Machine Learning, which Raphael talked about this morning, then you can go and upload data to Azure and use data on that and do your analysis in that. Now the thing with R is that the data lives in memory, and what that means is it restricts this amount of data that you can look at. So if you want to go and look at large data sets, there's a few things you can do. One is obviously use Azure. The second thing to look at is Revolution Analytics provide a package called R Hadoop. So you could go and look up and analyze your data in Hadoop. I feel it's okay to talk about Revolution Analytics because Microsoft are buying them. So that's why I told you to go off and look at that. You can download that as well. Have a look at that at the site. And then we assign our data. So the Benford analysis package comes with a sample data set, which is called corporate payment. So we can have a look and see what's in the data, corporate payment. So actually I'm going to execute that data first. You have to assign the data. So what I want to see is, oh gosh, sorry. Let's see if we can see what the data actually is. Okay, so it's probably going to go off and ream lots and lots of data back at us now, which is exactly what it does. So I'm just going to see if we can scroll back. It's too much data to see. So what R does is it gives you some handy commands so that you can see just little bits of the data. So this one is called the head. And what that does, I hope you can see it. Yep, I'm not that tall, so I'm not blocking it. And what corporate payment does is it gives you just the first 6 kilobytes of data. So we can see just exactly, we have zoom in so we can see that a bit better. So that's what we've got there. We've got some sample data with a vendor number, the date, the invoice number, and the amount. Yeah, so that just gives you some sample data to go off and play with. Now, because it's got the head, it's actually got the tail as well. And then that lets you see the very, very last few rows. So we can see that data, just the last 6 lines there. So what we can do as well is summarize the data. Okay. So I talked a little bit about people don't do or don't always do descriptive statistics on the data just to have a look at it. So the date one doesn't really matter that much. All it does is give us the first date, the year 2010, and it gives us the maximum date. So we've got a year's worth of data here. Again, it's just fictional data. Now R is recognises your data types as well. SSIS and Excel does the same thing to a certain extent. Tells us that that is character date. And the same with the invoice number as well, that it's character data. So what we can see here is, straight away, we've got a minimum, minus 71,000. Now that could be a refund of some description, or it may be if it's incomes and out, as transactions cancelling each other out. We'd have to go and look at that. So it gives you the quartile, the first 25% point, and it gives you the third quartile as well. We've also got the median and the mean, and the maximum. So we can see exactly what the data is there. So that's 26 million. Yeah, so that gives you a summary of the amount. So what we can start to do is use some of the graphs that come with the package. Again, it's just one line of code. Nothing is plotted here at the minute, but what I want to do is print the data out. So here we have just a few lines here. What I've done is, on the data set called CP, what this does is, it uses the function Benford. And what we see here is the dataset name. The dataset name is called corporate payment. And you probably see the $sign, which is right in the middle. So in R, if you want, you can use your dataset here is called corporate R. And the $sign just simply tells you the next thing that comes after that is going to be a column name. Yeah. So when we looked at our data for corporate payment, we had a column called amount in there, and the way that you reference it is just simply a $sign. So what we have here is our variable, which is just simply called CP, short for corporate payment. And then what we've done is plot the corporate payment. When we do a plot, just that simple bit of code there, then that goes off and plots the data for you. It doesn't always get it right, a bit like Excel. The first time you load up some data, through the chart at it, it does something a bit funny, but it's certainly worth having a play around with it. You'll probably know as well that doing this sort of chart takes a lot of work in Excel as well sometimes, if you try to do 6 charts next to each other and try to get them synchronized. So just to look at the first one, when we look at the invoice payments here, the red line, which goes down here, is the data, or the distribution of what you'd expect to see in Benford's law. So out of all these invoices, we see here that that is where 1 should be, then 10, 20, so on and so forth. And then what we have is, you can see that the actual invoice compared to the Benford's law it looks fairly similar anyway. But what we have here is an invoice, quite a big one, and it sticks out a mile. So again, it's not the be-all and end-all, it's just a start. But you might want to think, well, why are there so many invoices starting with that amount? So when we start to look at some of the stats in the data, you might look at it and think, well, actually, I've got an outlier here. Why is that? That's a bit strange. And then you can see that there's some differences here, and that might interest you to look at it as well. If you want, you can export these as pictures if you want to show them as something else. Now, if you want to get the data back out, you can export the data set as well, or you could import them using command lines. You could also connect to SQL Server as well. If you want to do that, the package is called RODBC. I've just stuck with the corporate data set at the moment, but we will start to wrap up. Okay, current slide. Okay. So just to summarize, can you see that? Kind of. Well, that's not too bad, sorry. So data visualization as well as stats can help you to audit the data and find things in there which look a little bit strange or a little bit funny. So Benford's law is just one of these statistical anomalies which seems to hold for certain things and not for others. I recommend, if you're interested, go and look it up in Wikipedia. They've got some sample data sets. Look for outliers, look for things that are a little bit funny. Again, it's quite easy to plot the resolution. You can see it quite simply. So go and try it with some data. And that's just an example of Power BI. But Benford's law, just to summarise, is one of these things you do when you're analysing data. It's not the final word, but it might start off a whole load of questions for some data. Again, it's about showing everything. So it's seeing me march down the corridor one day to come and ask you about why you're collecting the median wrong for the last 4 years. I'm sure that you wouldn't, but I'm sure I will meet other customers who will. Think repeatable principles, testing, and then passing it to someone else to test. And that's what I like about art as well. It gives you the ability, and I do this, give someone else my data and my code and ask them to check, because I want to be sure that everything's right. Okay. So with that, it is 5 to 6 in the evening. Does anyone have any questions? No. Well, I hope I see you all at the party later tonight. I want to thank you all for your time and coming to this session at the very end of the day, and I will see you at the party later. Thank you.